Okay. All right. Thank you all for joining this session. My name is Ken Talbot. I'm with Utah Department of Transportation. I will be moderating this session. The session is Structural Digital Delivery Design Perspective. We have Daniel Jensen and Courtney Hoyle. Before we get too into that, if you are tracking your sessions, the 6-digit code is right there on the table for the CVent app, if you want to utilize that. That code will be good for now through the end of the session, then it doesn't work anymore, so it's a one-time use. So Daniel has over 9 years of experience in the structures. Do you want to go by Dan or Daniel?
I go by Daniel, but it doesn't matter.
All right, Daniel has over 9 years of experience in the structures transportation industry. He is the leading effort in outlining and creating various digital delivery networks across the country. Courtney graduated from the University of Texas at Austin with a degree in architectural engineering. She spent her first year in Houston working in the oil industry, designing on and offshore structures. She has worked for the Texas Department of Transportation in the Bridge Division for the past 17 years on a wide variety of projects, including precast concrete network, tied arch, curved spliced concrete U-girders, and monotube sign structures standard redesign. Currently, she oversees bridge standards, ancillary bridges, shop design, shop drawing review, production groups, and the digital delivery initiative for bridges. So I'll turn the time over to them.
Thank you. So as Ken mentioned, structures digital delivery, going to kind of concentrate more on the design. So concept up to when we deliver that project to the contractor here. So just a little overview of some of the tools that are out there, and this is not an exhaustive list, but just some that I've used, the company have used, and others. So Bentley software is out there, kind of has their two different packages, Open Bridge Modeler and then Pro Structures. One's for more of that model development, and then one is for that detailing. Allplan has a very similar structure where they've got your bridge modeling package, and then Allplan Bridge, which they've been using overseas for probably 20 years or so, is really that detailing sheet creation package that they have available there. Other solutions that are out there from the Autodesk side that implements with Autodesk software is Sophistic, and then other one is Tekla Structures as well. And all of these can be utilized to create a really impressive 3D bridge model. So really the first step of any structures project is building out that workspace. So those line styles, those levels, that workspace, so that every time you start a project, you're starting from something that's standard, right? So you've got standard templates, pier templates, deck templates, and each DOT is going to be different on this, and they can create that workspace. Sorry, I'm not that exciting. I apologize. I'll try better next time. But yes, anyways, that workspace can be delivered so that it gives you that solid standard on any project and kind of that repeatable process. The nice thing with these packages is, depending on which one you're using, you can have multiple users on these projects at a time. So say you're doing a project with 3 different types of bridges, you can have 3 different users each on those bridges. But the nice thing is if you have someone else that needs to work on those, you would have to check that in, and then that other user can come in there. And depending on how you set that up, which you can see here, there's 5 or 8 different files here. Those are all the different detailing models that are available. And anybody can go into those at different times and update those models. So you can have a large team, small team, set that up so that you have various different users getting in there and updating those different models. So I mentioned starting that project. Different manufacturers are going to provide you with different data. But really, if you can pull in all of your roadway information, your drainage information from those designers into your design package, into your bridge design package, you don't have to do that. You're pulling all of their data already, so you don't have to recreate that. Say you're in kind of a concept phase, though, and you don't have that information. The nice thing is all these design packages have that ability to create a vertical or a horizontal alignment for you in your bridge design software. So you've got that ability, but the most efficient way is to just pull that information that's already been created. And that's really efficient. You can update that relatively dynamically. so that you have that updated alignment and profile, and if there's a change down the line, you can just update that and your bridge will update for those new changes. So really starting with that information that you get from the roadway, now you can really just start modeling. And it doesn't matter if your bridge is a simple bridge or if it's a complex bridge. A lot of these have kind of wizards that you can just throw your design information into and then start your bridge design or start your bridge modeling. And you really get a very good looking bridge in probably a half an hour to an hour. You've really got that solid understanding of where that bridge is. It's located geo-referenced, absolutely correct, vertically, horizontally, and then you're bringing in all those templates that I mentioned as well. So you've got say a UDOT barrier or a TxDOT barrier. All that information is there correct. You've used those templates, but it's not perfect. So what you have to do then is go in and create, those chamfers or different varying cuts and stuff that you need for the design that you've already done, right? That the design is kind of done over here. I need this model to submit as a digital delivery document. Now I need to make these small little adjustments, changes, that type of stuff that's not available within the basic software, or I guess the basic parametric modeling. You're gonna have to come in and modify those elements for that. The nice thing that I've also seen as well is building templates or cells, all plan, they call them Python parts. And what that is kind of standardized items that you can just bring and drop into your models. So say you have a drainage box here, that cell is already created, it has all the reinforcement, the standard reinforcement in there, everything that you need. You don't have to model it because it's already been done for you. It's already in the workspace. You just pull that in, drop it at the location that you need, and voila, there it is, nice and easy. This can also be done for linear elements and linear repeating elements, such as like along a barrier you want various different signposts or masts or something like that. You can bring in those standard posts and then locate those along that bridge length. So the next step is, once you've got that bridge model built, that solid model built, now you need to detail it. So a couple of those solutions out there, ProStructures, Allplan Engineering, that is the detailing software. That's where you bring that solid element in and you can reference that directly in. Now you've got your shape, and then you can start applying your reinforcement. A lot of the solutions have tools that you can just quickly say, I need this mat up here, I need this mat, and then quickly define that reinforcement, and it'll throw it in there really quickly. That's not to say that you don't have to modify it after that a little bit. There's always going to be crazy elements like your diaphragms, a little bit more complex elements that you're going to have to go in and create that different reinforcement for. And that's really what takes the time with detailing, is those little bit more complex elements. Those simplified elements, though, if that 3D model changes, that reinforcement is tied to that 3D model. So that reinforcement can adjust based on those parameters that you've initially defined for, say, that slab or that column, whatever element you have there. So some cool things with the 3D model and the 3D software that you have available here is automatic reporting for elevations, quantities, deck beams, bearings, footing elevations or pile tip elevations as well. And a lot of those, you just click a button, boom, there's your report on your elevations. And the nice thing is you can then send that out to an Excel file for all of your screed elevations. Now you've got an Excel file that you can send the contractor. They don't have to retype in that data later to put into their software. But also, being that it's PDF or an Excel file, you can print that out so that you can QC that. And you can see some examples here of some of the QC that I've done on some of those reports. Quantity reports, look at that, compare that to what the model is outputting, making sure that's correct. You still have to verify the software a little bit, but also compare that to some external calculations. And that's one thing that I want to stress with QC is you still have external calculations for a lot of different elements. For your quantities, for your elevations, assuming that the model is perfectly correct is a bad assumption right now. you need that external calculation to verify that everything in the model is correct, but that's also a really good way to verify that everything that you have available to you is jiving with each other. So we've got our 3D model, and now we've got our detailed model as well, right? So we have all that 3D element information out there, but where's the data that's associated with that? And that's the most important thing with 3D models is it needs data. We need a digital as-built, we need construction data. So applying that and getting that into a form that they can utilize is important. But not everything can be created in 3D, so we can still create 2D details. We're not calling them sheets, they're details now. But the details can be created from the model, or maybe it's a standardized detail that we're creating from the DOT and just bringing that detail over and then modifying that based on the digital delivery project. You know, maybe we don't need some elements because we're already including that in that 3D model. And then I mentioned that data, getting that data in there via attributing item types or attaching different types of reports. You can see we've got PDF reports for our special provisions that we're some way attaching to that model. It doesn't have to be directly attached to an element, but the idea is to have kind of a single source of information for the users to be able to pull any bits of information that they need about that model from one area, right? I mentioned the Excel tables, so we can include those in there, such as like our elevations, beam details, but then also those 2D details that I mentioned, making sure that those are in there. As far as the attributing, getting attributes on our items, the software is not going to know exactly every attribute that you need on those elements. So you're gonna have to go in and put in, say, you know, the material types or the cover type, you know, the type of reinforcement bar, whatever it is, and attribute that to the element. But then you've also got pay items, and depending on the type of project, if you got a traditional project, you need those pay items in there. And this is a great way to tie those pay items to an element. They simply click on it, they see exactly what that pay item is, the inspector knows how to pay or what to pay for that item that they constructed out in the field. A little bit more on review. You can see here on the left, I like to use checklists for my model review. Just all the items that need to be checked in a model, I'll go through and look at those items, check them off if they've been correctly modeled in there. But then external reviews, and this is kind of a hot topic right now. I'm not gonna say there's a perfect solution out there, but we really need a good solution of how to review that model from the owner's perspective or from the design reviewer's perspective. And the best option is to do that in 3D, right? To do that with having the model so that you can rotate around that, see all the different elements, be able to click on an element, create an issue, say what that issue is, maybe attach a picture or a report or something to that, and that gets assigned directly to the designer. The designer can then address that issue, change the disposition, reassign that back to the reviewer, and now there's a paper trail there. And then ultimately we're able to report out on this, this review tool so that we have that audit for later on as well. A couple other items I wanted to hit on that are really fun about having a model is having that tie between the design model and then just a geometric model. So if we have a geometric model, why should we recreate a finite element model for that? Well, we can tie that and export that over to some of our finite element software via external links, but there's also options for direct links as well, where that design or that geometric model can be sent directly over to some of those, you know, maybe they're Bentley-owned software or all-plan-owned software, or maybe it's an integrated spec check or something within there. And then there's that dynamic link back and forth between geometric and analytical models. A little bit on clash detection too. This has been really helpful for horizontal clearances around railroads, vertical clearance if you're going over a roadway or a railroad as well. But I like to hit on the differences of hard and soft clashes. So a hard clash would be major design elements that are actually interfering with each other. So that could be a roadway element and a bridge element that are overlapping. That is something that needs to be updated in the model and changed. But a soft clash could be something that is reinforcement with a conduit or something in the barrier. Now, that reinforcement could be adjusted, or maybe it's two reinforcement bars that are just, overlapping a little bit. The field crews can adjust those slightly. There's really no need to go through those 1,000 different clashes that you're seeing in your model and adjust those, by a millimeter or two. So a little bit on some of the phasing, and I've had a couple people ask me, how do you do phasing? What's the best way to do that? I don't really know. We're still looking at that. But one way that I've seen has actually worked pretty well is just having different models for those different phases. Or say it's a slide bridge, right? You've got the initial location, you model that, now you got your final location. All you have to do is just adjust your horizontal alignment, or horizontal offset, sorry, in that new model, and now it's in its new location. So you've got, say, 4 different models, separate models, of kind of the same bridge, but in just different locations, or maybe certain aspects of that are cut off due to construction phasing. And then I'll show you how those are then combined together here at the end and shown in a way that the contractor can identify that and understand that phasing. Some of the export formats, this is something that you probably hear in a lot of different conversations of, what's that universal file format? That's something that we're looking at as well. How can we get this to, whether it's an IFC or some of the other universal file formats out there, so that we can then import that into other design software, other geometric software. That's something that we really need to concentrate on as an industry and get a better understanding of that. So I was mentioning with the phasing, how we bring everything together. What we're doing now is doing this via a container file or a federated model. And that is just bringing all of your different discipline file information, your reinforcement files that I mentioned, bringing that into a single model environment. And that federated model might not actually have any information directly tied to it, but it's bringing all of this data and models into one so that you can consume that. We could bring the existing structure in there, fill quantity information, and bring that all into one environment there. And you can kind of see some examples of how that looks, or how that looks with the grading, the roadway. All of those models are separate, but they're brought into one environment. Here's kind of a little diagram of what that looks like, where that container file is, roadway design information, structures design information, that additional details, sheets, reports that we're also bringing. Those are tied to one of those models, so that information is being pulled in as well. And then that's available within that container file so that we can view that in various different forms of software. Bentley has their solution, Allplan has their solution, Trimble has their solutions of how to consume that data. There's also free solutions out there as well, so people don't have to buy software to be able to view this model. Probably the most important thing with these models and compiling all this data is making sure that people can understand it and read it, right? So saved views is a way that we've been able to help reviewers, contractors, down the line asset management and inspectors to be able to consume a large amount of data, right? If you've got a corridor of 5 miles with 5 different bridges, you bring all that into one, that's a lot of data. So how do we consume that? We break that into different models, right, or different saved views. So there could be a model for one specific bridge, just the foundations. Well, this list on the right-hand side here, I don't expect you to see that, but that is a various list of all the different saved views for this one bridge that we have here. We've got elevation views in there. We've got 5 different views of the abutment, a single abutment. We've got reinforcement views. We've got a framing plan view. And if you think about that, it kind of sounds like we're creating these sheet views. That's really what we're doing, is we're taking a 2D document, turning it into 3D, and then we're building out that sheet that people are already comfortable with, or that saved view that people are already comfortable with, and presenting that to them. We're helping them through the process and stepping them through the process by getting them something that they're already familiar with. So a little bit kind of just on the project in whole and structured delivery in the whole. I wanted to hit on this before I close and turn it over to Courtney, but some of the role changes that we've seen. The traditional project manager, say a lead engineer, lead structure design engineer, the design engineer, which is really doing the grunt work, they're putting the design calculations together, they're helping with the sheet creation, and then you got your CAD tech. Those roles are not disappearing. We still have those people. We're not having to let people go. We're not having to add people either. But those roles morph a little bit. We still got our PM, we still got our lead engineer, we still got our designer that has to run through those calcs and create that information, right? But that CAD role, they kind of turn into more of a design role. They're having to get into the model, create that model, help with rebar detailing, and detailing on the elements, pulling out reports, helping with quantity generation. So that role is not getting rid of. There's morphing into a little bit different, a little bit more capacity there. But we're adding this center model coordinator. And that is a role that we're not, again, bringing in somebody. That's just somebody that has to understand the process. And that's really what's important with digital delivery, is getting someone within your organization that is going to be that champion, that person that understands from A to Z, looking at the model, being able to pull all the different discipline information, discipline models together, creating that federated model, understanding how to create the SAID views, understanding how the contractor utilizes it, throwing in ideas, and then helping the whole team put together a really good package for the client, the contractor, and effectively getting a really good product. So with that, I'll turn it over to Courtney, and she'll give you an idea of what TxDOT is doing in their journey of digital delivery.
Thank you, Daniel. So as Daniel said, this is going to be more of the TxDOT perspective. So kind of our journey through it, where we were, where we are, and kind of where we're looking to go forward with this. The current state of things right now, when we were developing our workspace for Open Bridge Modeler, we're really focusing on our standard bridges. We have over 800 standards. We're not getting rid of our standards. We want to keep our standards, but we are requiring a model moving forward with our standard bridges. And so we wanted to make sure that if we could do our standard bridges within Open Bridge Modeler, then we'd be able to do most of the bridges we do. There are going to be some more complex ones that we need to look into and stuff, but for the most part, all of our stuff will be there. Also part of the BIM for Bridges and Structures Pooled Fund Study, and so I've kind of been involved with kind of working on the IFC language, which is the universal language that Daniel was talking about. And we are getting some movement with that, as well as like data standards. That was presented yesterday, so I'm not going to touch on it too much. But we are also excited for that. That way we're not tied necessarily to a software. And part of this has to do with the design software, right? So the model is a model for structures. For roadway, the model is the design. But from a structure standpoint, the model is there to hold data, like Daniel was saying. So it'd be nice to be able to, if we're not using necessarily the same suite of software for our design and our modeling, to be able to take that model and put it into a different software. As of right now, we've done a lot of bridge 3D models. A lot of it's been more for public meetings, presenting the information. We've started doing more about vertical clearance checks. That bottom picture there, it's a bent cap over a lower roadway. There's 8 direct connectors in this area. And to try to figure out that geometrically without having a 3D model was very complicated, to say the least. So we were very happy to have the 3D model to kind of check those clearances. So just for some pictures is kind of what we've been doing. One of the first ones we did was a widening, and we really wanted the model and to show the construction sequence. This is one of the more complicated widenings. Every bin is at a different skew angle, and part of that is to try to get the new clearances for the lower roadway, or the railroad, right? Because when it was built, they had different horizontal clearances. Now they want the larger horizontal clearances, but attached to the same bridge. So this was kind of a way for us to work with roadway, show what we have, and also kind of show the construction sequence. We've also used it to show the historical committee what it looks like. This particular project we were doing a rail retrofit on, as well as some maintenance work on it. And they were concerned that if we replaced it with a MASH crash-tested rail, that they wouldn't preserve the historic look of it. And so as you can see on the top, that's going to be the historic rail. And then on the bottom is the MASH crash-tested rail. And so this was one of the ways that we could present the information so that they'd feel more comfortable with the new design that we were proposing. We've also done a pilot project for construction. So what we're interested in is, okay, we have a 3D model. How do we use it? How are the contractors going to use it? How are the inspectors going to use it? This particular one was specifically for the construction inspectors. It's still ongoing right now. But you can kind of see on the bottom is kind of the rendering picture that you would show a public meeting. But you can see on the top, that's really what the construction inspector is going to be seeing and kind of how that works. And so we were doing a trial in Synchro. And again, that project's still undergoing. But as you can see, we've kind of changed how we're looking at these models. They're not just pretty pictures necessarily. We are looking at exactly how we're going to be utilizing it for more information and down the life cycle of the bridge. In June of last year, we did have a memo that stated that all of our consultants, districts, divisions, any bridge in Texas, they will need to design or have a 3D model. And when we talk about 3D model, we're actually talking about the intelligent 3D model, not just a rendering, but something that has information in there. We are not to the point of using them as contract documents yet, but only so many bridges come through the bridge division, and for us to get the Bentley software up to where we have the confidence level in it to provide it as the contract document, we wanted a very wide range of input and feedback. So we opened it up for the consultants. So as we get that back, what we requested is a comparison of the quantities, the geometry, such as bearing sea elevations, and to be verified by other means, and have them send us a memo back letting us know kind of what they're finding. With that, we've also asked them for any user enhancements or any trouble they came across, right? We're working closely with Bentley to try to get the software where it needs to be so that we have confidence when we say, here's the contract document, and not say, here's the contract document, but don't use X, Y, Z, right? We want to make sure that we've got the confidence in it. We are still using 2D sheets for the contract documents. Internally, we've been working on creating the 2D sheets from the 3D model. And I guess in that case, it would be details, right, Daniel? not sheets anymore. But we're not mandating that of our consultants, because I'm trying to take it step by step. That's why we're not also mandating reinforcing yet. So the question that I got when this came out was, well, what do you mean? You want a 3D intelligent bridge model. What exactly does that mean? We're still working out level of detail at different submittals and things like that, but in general, we want the geometry of the bridge. We want the slab, beams, abutments, wing walls, caps, columns, foundations, as well as rails. And so just so that we have all that information there, and you can see what the bridge looks like. It also helps when you're going through with the roadway and you put them both together and make sure they match up. We actually had a bridge recently that we did, the same one actually with the vertical clearance one, where the bridge was 3 inches higher than the roadway. And so we went back to the roadway designer and said, I think you have a problem, can you look into it? And so we got to fix it before it went to construction, so it wasn't a change order. So these models have been helpful with that. We're talking submittals for 30 and 100% require the model. I know the milestones are really going to be changing because, what does a 30% model look like? You're going to have to probably do more than 30% of the design to really get a 3D model. But what that means to us is when we're reviewing the preliminary bridge layout, we want the model with it. Because you have a layout, it has a bridge, send us the model. And then at 100% at the end. So really it's whenever there's an ORD model we want the bridge model. We want to look at it from a 3D project, not 3D elements. And so we're trying to get that across. If the district wants the model at more stages, then they can do that. But those are the two main ones that we need. So, as I said, bridge division, internally, we've got a workflow where we can create the plan sheets from the 3D model. These are some of the plan sheets. They look almost identical to what we had. There are things that you have to kind of work through by turning on enough layers and where exactly you're cutting it and things that we're learning that way. Once the new workspace comes out for 10.12, we will be posting the workflow document as well as our new training guide. And everything that we create internally, we're posting. It's open to anybody, our consultants, other DOTs, whoever wants it. We're trying to get that resource out there. We're all learning together, so. This is what a bridge layout looks like from a 3D model. And honestly, from my standpoint, I couldn't necessarily tell the difference. I do know there was a lot of heartburn going into this, trying to turn off the right levels and get the right cut. When it's a curved bridge, that's a little bit harder to kind of get that profile view and things like that. So we are working with Bentley to try to make it so we can do this better. When we do modify the model, the details also get updated. So. As far as kind of what we've done, like I said, we're working towards being able to do all of our standard drawings, and right now we can. So we have templates in our workspace, and these are just the standard templates that we've created. 8.5-inch deck, railings. I show this picture in particular to show the two different types of rails. So the solid rails, like our SSTR, is going to be a template, so like one that you typically use. When we have the post and beam and we've got the spaces, we use 3D line styles. And so when you do the 3D line styles, you draw a line and it renders like what you're seeing. Now, what we came across, like we said, we have stumbling and trying to figure it out. When you cut a cross section, a 3D line style, you do not see the outline of the rail because it's the rendering. So when you do have to go through and do the cross section, you do have to do kind of a solid barrier that you would turn on and off levels depending on what you're looking at. We have our beams, so our tech skirters, box beams, slat beams, all of those templates are there. We also have bents for our standard bridges. So for a specific roadway width, we have the bent that you'd see on our standard details as a template. So you don't have to mess around with how many columns do I have and things like that. We've got it related back to the standards. And then abutments. So one of the things with the abutments is we needed a break back, and Bentley couldn't do the break back in a regular template. So we created a parametric cell that is in our workspace, so you can do the break back. So we found a way to do it and still put it in our workspace for the end user. We are trying to make this as easy for the end user as possible. And we're always asking for feedback of anything else that we can add to our workspace to make it easier. One of the other things that we did, I guess in April of this year, we have 3D bridge model templates. So what you're seeing up there is a DGN on our website, on our standard website. You pull the bridge down, you attach it to a roadway alignment, you change the width of your structure and your span lengths. And if you need more spans or whatever, you can add those. But you have a bridge. And so the idea is we have the bridge sheets for our districts. It was really easy to do standards. They pull the sheets. We have a spreadsheet that does the elevations. They just have to fill out an EQ table. And they're like, and now we have to do a model? So we wanted to supply them with a model as well. So there is some learning. There's time associated with the learning curve, but we do have that. The other place where this is used is for the roadway designers, because when you're doing the bridge layout, you might not have, well, you don't have the bridge design, right? You've got generic things in there. And instead of using ORD templates or something like they're doing now, we're like, here is an OBM template, reference it into your roadway file, and then cut your sheets. That way, from the very beginning, we've got a 3D project, including the bridge. Even if whatever bridge they reference in isn't exactly what it's going to be at the end, at least they have the 3D bridge in there. So these templates can be found on our Bridge Standards website. So I don't have a web page on here because it's easier just to Google text.bridge standards, and you'll get there a lot faster. So, but these are kind of the different beams and different roadway widths. We really did it more towards number of girders than roadway widths, because you can change the width of the bridge fairly easily. The other thing that we've started discussions on is kind of, okay, what are we gonna do with this asset management wise? What kind of information do we need? So as we're building the templates and the models, we wanna know now what kind of item types or attributes would be helpful in the future so that we're not doing it retrospectively. So we're kind of working with them. It's still kind of on the early stages of that. We have put in the elements like for the inspections. So we put in the element numbers. So if we chose to do that and the inspectors go out there, they can put them in the model. Not sure what that looks like or if that would even be helpful, but we have them there. We do have a research project that's kind of looking into, okay, if we go out there and we use a drone, we get images, how do we manipulate that information? Where do we store the information and how do we use it? And so that's something that we do have a research project on. So kind of a timeline, this is kind of where we are now, right? That's everything we've kind of looked into at the moment. So on here, think of these all about a year later, because we have 2 months in 2023. But in the next 6 months, we're looking at identifying a pilot project. And then about in a year, being ready to use those standard bridges as the 3D contract document. Because again, we've got the models pretty solid for our standards. It's a matter of trying to figure out how we link them to the other files. In about 2 years, we're looking at putting the reinforcing in the bridges. Our workspace does have all of the reinforcing details that you need for pro structures, but I was pretty sure that people would not be okay with me saying you have to learn OBM and pro structures at the same time. So again, I'm trying to piecemeal it. We have the resources, they're there if you know how to do it. If not, don't worry about it yet. About a year later, kind of more reinforcing for the more complex bridges. Then looking into the asset management in more detail, and then kind of data utilization. Because I feel like at that point we'll have more data, so we know what it looks like, so we know how to use it. Because right now, yeah, we have a bridge, but what kind of data do we need? What kind of data does the contractor need? Fabricators, we don't even know that part. So it's gonna be really hard to know how to use it at the end of the day. So for pro structures, again, like I said, in our workspace, we have all of the detailing per our detailing guide and everything. Just trying to take baby steps. So we're messing with it in Bridge Division, but I'm not making other consultants like produce that as the model. This is kind of an example of what it might look like if we wanted to do links to the standard details. So you can select an element and attach it to a PDF or a link or an Excel file and have it go that way. There's some things with this because if we link it directly to the website, our standards update. So I'm thinking it'll probably be more towards a project-based thing where we have a location where we put these for our project so that we know what version of the standards we have. These are the resources that we have out there right now. And so there's the website. We do have a more detailed description of what's in our workspace for a structure standpoint. And then there's an email address there if you have any questions or want to talk into more detail or whatever, feel free to email. I'm open for feedback or discussions or anything else. Like I said, we're trying to learn just along with everyone else. And so I appreciate any feedback or discussions. Some parting thoughts. So if you haven't started yet, it's not going to happen overnight. I've been presenting and doing models and stuff like that since 2016. So, I mean, we've come a decent way, right? My focus has really been for the design model standpoint. Part of the things that needed to happen were kind of, how are we going to let it for contracts? How are we going to sign it? You know, more of the fine-tuned details. My focus right now has been kind of getting the software to where we need it to actually have a design model. This is a teamwork effort internally within design section, as well as making sure that you're communicating with roadway, hydraulics, other things. You know, all the departments kind of come together on this. So you need to make sure that you're talking together. Otherwise, if you work in each silo and you go, well, this is my idea, and then you look at roadway and you're like, well, those don't really work together. And I'm the type that wouldn't want to go, here's your roadway model and here's your bridge model, have fun. I'd rather it look like it's seamless, as much as it might not be at the beginning. At least present it seamlessly at the end. One of the things that we did come up with is culverts. So a 20-foot or longer culvert, right, is a bridge. The cells and the way that you can detail it is an ORD, so it's really more a hydraulic cell, and that's how you use it. We've created one that looks like a culvert in OBM, but I wouldn't suggest it. We used a spread footing, I think. But really, this is a paradigm shift. So instead of thinking, how do we fit our traditional ways into the software, we really need to be looking at what do we want? Like, what are the possibilities? What, you know, high in the sky, what do you want out of this? From our viewpoint, our goal is to make sure that we can get the information to who needs it in the format that's most useful to them. So for fabricators, that's probably more of a spreadsheet than a 3D model. If you're thinking about it from either a steel perspective or even our pre-stressed beam designs that we use, it's more useful for them to have a spreadsheet than trying to dig through a model. So we're trying to work through exactly how people want the information, but at the end of the day, that's our goal. And so I've been caught up on this model and 3D model and how do we cut sheets, but how do they need the information? And then how do we need it back to then be able to use it? So, but you know, the sky's the limit. You can think of different ways and how you guys want to do it and just, you know, be creative and have fun with it. Kind of what I suggest. I'm lucky enough to have somebody that enjoys doing this, and he has a computer science background and an ORD background and a hydraulics background and an inspection background. So it's really hard to find people like that, but it's helped a lot with trying to create the workspace and trying to figure out how it's going to connect with the different departments and things like that, because he can talk the speak of all the other people. So, and that's my information. Again, it's the same email address that I had before. That way a group of people can respond and you'll probably get a faster response. I try, but there are some people that have that know the knowledge more than I do that can respond quicker to certain questions. One thing I did want to end with before we open up to questions is safety moment. In Texas, we're really big on the safety. Unfortunately, it's been since November of 2000 since we've had a deathless day on Texas roads. And so our kind of the message we're trying to get out there right now is to kind of end the streak. And the three main things is obey the speed limits. They're there for a reason. Buckle up. About a third of the deaths are because people haven't buckled up. And there's been decades of saying, hey, buckle up, right? So I don't know how else to get that message out. And then also putting down the phone and distractions when you're driving. But I figured it's a good reminder. We've all traveled here, so to make sure that we make it home safe, just kind of keep it in mind. And with that, I open it up to questions. Yes. Hi.
You talked about coordination, communication. One of the things I know that has helped us at the Iowa DOT is that we have a combined civil org workspace. Has Texas gone the same way?
Yes, so our workspace is one workspace for everything. That being said, it's still, so when we deploy it out to consultants, it's one workspace, but there's still the OBM stuff and then the roadway stuff. there's had to been discussions about line styles, feature definitions, levels, because levels that are in OBM are not in ORD. And so it took us a while to kind of discuss through that and say, can you please put them in? So that way it goes back and forth. When you reference it in, I believe the levels get there, but if you which you should never do, but it has been done, copy and paste it, they don't show up because that's not a level. Yeah, that was eye-opening for me. I was like, you did what? They copied like a 2D image over to their 3D model. I'm like, why would, but, we're learning. So that was one of those things where we need to have the same levels, the same line styles. We need to have the same feature definitions and things like that, especially when you're annotating and things like that. But we're working. We have one workspace. We're working to make it more cohesive within itself. You have questions for Daniel, too. Yes.
Do you all have a plan on how you're going to sign and stamp these 3D deliverables?
So Jacob is the section director for our digital delivery group, and he's also part of the organization that's really looking into that. Since they're already looking into it, I kind of stay out of it. I'm trying to wait until they figure it out and then go into it. I do know that it's still up for discussion. We got a digital delivery consultant on board this past year, I think, and so they're also helping us with what's out there and how to do that. I do not know the specifics. I don't think we have any specifics at the moment, but it is one of those things we're looking into.
I just have one other question. Are you all basically mandating from the central office what your districts are doing and things like that? Is it like across the board, or are your districts kind of independent entities that decide whether we're going to do 3D model or not?
So for 3D modeling, it is coming down from the administration. And so therefore, we are mandating across the department and through all of our consultants. Each district is a little bit different. They have different, Texas is big. So to try to mandate absolutely everything is not going to work for every district. But from a 3D modeling standpoint, yes, we're mandating it from the central. Yes.
Question, when you create these three-dimensional models of existing bridges and you're out there flying with drones, you got a lot of different consultants and all kinds of different drones and cameras. Do you guys have any requirements in terms of creating the level of model that you want, say like resolution of the camera, the number of pictures captured, all that? Anything you're driving out towards the field?
So I think this is really something we're looking at as a whole. I've been getting involved in some of those conversations as, do you really need a 1/4-inch tolerance in your bridge? I'm like, yes, I do. I can't help it. Yes, I do. And so there's been those discussions, because to do a drone or LiDAR or something, it's really hard to get that tolerance. And they're like, do we really have to put people out there with stakes? I'm like, we need a 1/4-inch tolerance when you're constructing it. If you're off a 1/4 of an inch here or there, it could, trying to place beams and things like that could get difficult. Part of the research that we're doing is going to be kind of aimed towards what do we need from an inspection standpoint from the bridge stuff. Our survey group is more involved in trying to figure out the details with how many images and stuff. But again, it's all in discussion at the moment. So.
Does it help to have an existing conditions model in that base survey, even if it's not going to have, some things the surveyors don't know what rebar is in the existing substructure or how deep the foundations are, but if they can model a simplified OBM model in their survey base, is that helpful for the designers?
So for me, it would be helpful to know where the bridge is. As far as what reinforcing is in it and how deep the foundation, that should be in the as-built, and that should be in our MBI database. Especially with widenings, but then again, the widening that we showed, there was an existing abutment out there, and they surveyed it 3 or 4 times and got a different bearing on the abutment each time. So, any survey is going to be a little bit off. But for me, it's helpful to know where it is to be better to know if I've got the vertical clearance or horizontal clearance. And even, like, that doesn't necessarily have to be 1/4 of an inch. Anything there would be helpful.
And as far as building, I'm sure your templates are according to
The new
previous
standards.
New standards, but they might not fit with the survey. Obviously, the as-bills are gonna be
Right.
slightly different in all of those particulars, but is it helpful for a survey modeler to try and create as close as possible an existing bridge as a solid and has those kind of features instead of just line work within already surveyed?
Well, for me, just getting the survey data is helpful. I wouldn't necessarily think it would be beneficial for the survey person to learn OBM and try to build an OBM model. It'd probably be better for somebody that's specialized in OBM modeling to do that, because they could use the as-built and build the elements and then place it based off of the geometry in the survey. I think would probably be a better use of people's time.
Just to follow along with that, we've typically just taken the survey from just normal, and we'll build out using the as-built existing bridge model, and then just use the survey, essentially calibrate that model so it fits in space properly, so that we have the existing model with our new models. But we don't rely on the survey to, we use, some key points out of survey just to graphically, geographically locate that so that we know elevation wise and all of that to place it, so.
Any other questions? I think we have another 5, 6 minutes, something like that.
When you're transitioning models from like prelim to final, I saw on your slide up there that you're using kind of non-parametric built solids. So are you finding that you're remodeling like abutments or piers when you're transitioning models from prelim to final?
Yeah, once in a while. We're really trying to concentrate on staying as parametric as possible up to that final deliverables. But yeah, I mean, absolutely, if there's major changes or changes like that between those different submittals, you're gonna have to go in and revise those elements and remodel those, yeah. Yep. Luckily, it doesn't actually take too long to revise the solids models themselves. The time I guess the stuff that takes the longest time is really the detailing, the reinforcement, that type of stuff. So if it's like a diaphragm that completely changes, that's brutal. It can be very brutal. Okay. Thank you, guys. Thank you. That slide did not change, I guess. I'm wondering if we downloaded it like right before you made the changes, because you made those this morning, right?
I made it before I sent you the.
I'll see if we can,
Before we post it.
yeah, yes, before we post it.
This is for,
Oh,
Thank you.
thank you.
Appreciate
thanks
that.
for presenting, guys.
Oh, of course.
Well done.
Thank you.
Good to
Thanks
see you
for
again.
moderating, yeah.
Oh, I got the easy part.